Welcome to another exciting educational video brought to you by Vision Concept Academy. So today we'll be looking at plane geometry, past questions, and we'll be solving them. Questions drawn from JAMB, WAEC, NECO, or GCE exams, all having this in view. So sit tight and enjoy the video. If you'd like to subscribe to our channel, kindly subscribe to our channel to get more content in these STEMs, math, physics, chemistry, and biology. Okay, so now I have a question on the board. It says, this question is drawn from WAEC 1998. 1998 WAEC past question. Okay, so it says, when an aeroplane is 800 meters above the ground, its angle of elevation from a point P on the ground is 30 degrees. How far is the plane from P by line of sight? Okay, so these are the options. You need to understand how this works. There are terminologies around angle of elevation and depression. First of all, you need to get a diagram from this particular story that will either cumulate to a triangle or right angle triangle. Then you will now introduce one of the trig ratios that is applicable to this particular scenario to solve it. So the first thing is to be able to change this story into a diagram. So you take it step by step. When an aeroplane is 800 meters above the ground, you do that one first. This aeroplane here, this is the ground, 800 meters above the ground. So the aeroplane is up here, understand? Now, its angle of elevation from a point P. So if this is the point P, angle of elevation from, anytime you see from, that is the reference point. So the angle of elevation from this point is 30 degrees. So angle of elevation is the angle that is made if this point is facing this other point on a line of sight, on a straight line. That angle between that line and the horizontal. So I'm going to draw a horizontal line from here to here. So this is actually horizontal, please. Just don't mind my marker. Okay, so I have, this is the plane. The plane, let's say plane is point X, and the ground is ground G. You understand? Point X up and ground G. So it says how far is the plane, that's point X, from P by line of sight. Line of sight means on a straight line. You see, so there are terminologies here that you are using to produce this diagram. So this diagram is the description of this particular story. This is the plane. Plane is 800 meters from the ground, G. And there's a point P. That point, from that point, angle of elevation is 30 degrees. If it's depression, angle of depression is now, let's say this point P. Angle of depression is, you are looking at it down. You understand? But we are looking at angle of elevation from up. Okay, now, having gotten this diagram, we say we should find this distance. Let me call it small x. Already, the relationship between this small x and this one and this angle is opposite. This height, xg, is opposite to the angle, and this x is adjacent to this angle. So I'm going to be using the hypotenuse to this angle. Yes, this is opposite and hypotenuse. I'm going to be using the trig ratio sine trig ratio, and I will come and say sine 30 is equals to opposites, which is xg, over hypotenuse, which is xp. Okay, so sine 30 is equals to opposite, which is small x, over hypotenuse, opposite, which is 800, over hypotenuse, which is small x. So I can take this up, so it will be x sine 30 is equals to 800. So x is equals to 800 over sine 30. That is, if you divide both sides by sine 30, you will get this relationship. So sine 30 is already 0.5. So by the time we do that, let me finish up here. X is equals to 800 over 0.5. x is equals to 1,600 meters. So the answer is D. Okay, we'll go to the next question. Okay, so I have this question on the board. It's from JAM 1999. So it says in triangle MNO, NM is equals to 6, MO is equals to 4, NO is equals to 12. If the bisector of triangle M or angle M meets NO at P, calculate NP. First of all, this story we can represent it in a triangle, in a diagram. So this triangle MNO, triangle MNO. So I have it like this, triangle MNO. So MN dimension is 6, MO dimension is 4, NO dimension is 12. But if the bisector means that a line divides this into two, this angle into two equal half, bisects into two equal half. So if I do a line to equal half, that's bisecting, cutting this angle into two equal half, and it ends at P, we should calculate NP. Now, because I am having a bisection of this angle into two equal half, I'll be having similar triangles, because triangle NPM, just follow my marker, NPM has the same angle with triangle OPN. So this is actually similar. Okay, so by similar triangle rule, I can write a formula like this. I can compare this side and this side. This side is, let me call this one angle A and angle B. No, triangle A. Okay, triangle A, triangle B. So triangle A is similar to triangle B. Why? Because at least one angle of the two of them is equal. We don't know about this one, but at least this one is equal. You understand? So if they are similar. Okay, so if they are similar, I can compare. I can say from triangle A, N over P, that's, sorry, NP over PO is the same thing as MN over NO. So I compare the base of triangle A to the base of triangle B. That is, triangle A over triangle B is equal to side A and side B. So I'm comparing. I compare the base of one to the base of the other, and the hypotenuse of one to the hypotenuse of the other. That's what I've done here. Okay, so I can quickly put my what's it called? My terms. So NP is equals to PO. These are lines, so please, these are lines. Okay, it's equals to, now line MN is given as 6, and line NO is given as 4. I can reduce that. Line NP over line PO is equals to 3 over 2. Okay, now let me just call this equation 1. Another equation I can get from here is that line NP, that's this one, we're looking for this one though, plus line PO is equals to 12. All right, because we're saying that NO is 12. So NO has inside of it NP and PO. Okay, now it is from here I will get this, from these two equations I will get NP. So let me call this equation 2. So I will say from equation 1, make PO is not Peter Obio. Make PO subjects. Okay? How do I do that? From 1, right? From 1. PO line is equals to 2 line MP over 3. So by the time this one goes up like this one goes up like this one comes down. just make MP solution formula, P solution formula. Understand? So I'm going to be putting this equation, this expression for PO inside of this place. So I'll continue like this. So I will write equation 2, and anywhere I see PO, I put this, right? So line NP plus, instead of finding line PO, I'll put 2 line NP over 3 is equals to 12. So I can multiply each term here by, from here now it's just equation, simple equation. Multiply each term by 3. So I will have 3 times this first term is 3 line NP. Note, I can use line NP to represent anything like X or something, but I want to leave it at line NP because at the end of the day, NP is what I'm going to get. Okay, so 3 line NP plus, this 3 will cancel the 3 that is implying this term. So we'll have 2 line NP is equals to 36. So 3 NP plus 2 NP is 5 line NP. Wow. Then 36. So I can divide both sides by 5. Line NP, which I'm looking for, is equal to 36 over 5. Line NP will give me 7.2. 7.2 units. That's the answer. 7.2 units. So this question tests our ability to, first of all, interpret the diagram. Interpret the question in the diagram form. Note how similar triangle comes in. Similar triangle has this relationship. I can compare sides of this one triangle with the corresponding side of that triangle, the same thing. So I get the relationship, I get the ratio that qualifies these two. Meanwhile, these two also can add to give another value. So even with this equation, it has to come into this particular question. So let's go into the next question. Okay, so we have a question on the board. It says, if point P with dimensions -6 or with Cartesian coordinates of -6 and 1, and point Q with Cartesian coordinates of 6 and 6 are ends of a diameter of a circle, find the radius. So this is circle, this is the point. So these are ends of diameter. So let me call this one point P and point Q, and their coordinates is -6, 1, and 6, 6. What this means in effect, let me put this one well, -6 and 1. What this means in effect is that the x coordinate of this point is -6, and the y coordinate of this point is 1. For point Q, the x coordinate, let me call it x2, is 6, and the y coordinate, let me call it y2, is 6. Okay, so I'm to find the line distance between these 2 points. The line distance between, so the line distance between point P and Q, I will call it PQ line. PQ line, square is equals to x, that is y2 minus y1 all square plus x2 minus x1 all square. Okay, let me put this in perspective. I will say x2 minus x1 all square plus y2 minus y1 all square. So we're going to be getting it. We're going to be using it. We're going to be using what we have here. What is x2? x2 is 6. So I will put it here. Let me just say PQ line square is equals to x2 is 6 minus x1 is -6. So it's minus again 6 all square. You see, this is x2, this is x1, right? Plus, then y2 is 6, this y2 here, 6 minus y1 is 1 all square. So I'll be having this one as minus is plus, so 6 plus 6 is 12. 12 square plus 6 minus 1 is 5, 5 square. It's equals to PQ line all square. So line PQ square is equals to 144 plus 25, that is, this is 12 square is 144, and 5 square is 25. So PQ line square is equals to 169, and by the time we get PQ only, is the square root of 169, which is PQ line is equals to 13. 13 units is the PQ line. PQ line is between this point and this point, and PQ is the diameter. But we're told to find the radius, and diameter is actually 2 radius, and radius is actually diameter over 2. Okay, so our answer is this 13 over 2, which will give us 6.5 units. The answer should be there, which is option A. So we go to the next question. Okay, so we have another question on the board. So it says a solid, this is WAEC 1997. WAEC 1997. Okay, so it says a solid is a cylinder mounted by a hemisphere. This is it. This is the diagram. So this is a cylinder here, and there's a hemisphere mounting on top of it. Calculate the total surface area. So when you see this kind of thing, don't panic. Just breathe in and breathe out. Then you now start looking at it. Look at it. Total surface area of these things. How many regular shapes do you have inside of this place that have a formula already known? That's the first thing you will say. I mean, you will think of first. How many regular shapes are found here? Regular shapes that have area that you know. Normally, you don't have area formula for this kind of this thing. So just try and defragment this shape into the various area, shape that you know their area, formula for area. The first one is that you have the curved surface of a cylinder. So I'm going to be saying total area or total surface area. Total surface area comprised of area of curved surface of cylinder, of curved surface of cylinder. Where is it? Which one am I talking about? This one. This is the cylinder. This one, where my marker is drawing like this. That's the cylinder. The curved surface of this cylinder. Plus area of the base of the cylinder. It's a circle, right? So I will say plus area of the base of the cylinder, which is this circle down here. So that's the second one. Then the third one is the area, the surface area of the hemisphere. This one that is here. With that, the formula again. Area of surface area of the hemisphere. Surface area of the hemisphere. So I'm going to be writing the formulas of this, each of the area of this thing in order. I'll start from the curved surface area. The curved surface area formula is 2 pi r square h. No, not square. 2 pi h. You understand? Plus the area of the base of the circle there is pi r square. And the area of the hemisphere on top is 4 pi r square over 3. Okay? That's for the hemisphere. That's for the hemisphere. Sorry, the surface area of the hemisphere is actually 2 here. It's not volume we're looking at. If you haven't gotten all these ones now, we're going to be putting in the values that we have here. So for the area of the curved surface of the cylinder, I'll be having it as 2 times 22 over 7 times the radius, what are we giving the radius? Is 7. Okay, is it in the question? Yes, it's 7. hold up. It's not specified in the question. Let me see. Okay, we're supposed to have this here as 7. Okay, so times 7 times height for the first one is 10. So that's the cross-sectional area. Okay, plus 22 over 7 times 7 times 7. Then the last one, the last component, that is one, this is already 2. So 2 times 22 over 7 times 7 times 7. Okay, so this component will give me 440 cm square, plus this one will give me 154 cm square, and the last one, I cancel, will give me 44 times, will give me 308 cm square, not cube, square. So when I add all these together, that is 440 plus 154 plus 308, I'll be getting 902 cm square, 902 cm square. So that is the curved surface, the total surface area of this shape. So in recap, just take a deep breath first, look at the shape. How many regular shapes can you that have formulas can you recognize from here? So that means you have to go back to the basics and know formula, area of a sphere, area of a cylinder, curved surface area, area of a circle, but because these are the basic things. Most of the complex shapes they bring are derived from joining or adding up these basic shape. So if you can defragment them in your mind, bring them out, find the area of all the components and sum together, you'll be fine, you get the answer. So let's go to the last one for this video. Okay, so we have a question on the board. It says that in the diagram, point B and C are on the horizontal plane. So point B and C are on the horizontal plane, and the line BC is 30 cm in the diagram. A and D are points vertically above the point BC. So A is above B and B is above C, respectively. Okay, DC, where is DC? DC is 40 cm. Okay, and AB is 56 cm. Calculate the angles of depression. Number 1, B from D. I told you in the previous question that anytime you see depression, angle of depression, from, you are looking, here is a reference point. Where you have from is a reference point. So from D, meaning that this is where I'm going to be standing to be getting the angle of depression. Okay? And number 2, A from D. So if it is the first question, B from D, I will now draw a line like this, broken line. This line is not part of my initial diagram. Alright, I'll draw a broken line. So I'm going to be standing here. Angle of depression actually is the angle that, if I draw my cardinals on top of this diagram, the angle of depression will be this angle here. This angle here. For me to get this angle I will call it, let me call this point ABC. Let me call this point E. Point E. I need to change my marker. Just hold it. Okay, so the angle of depression is actually this angle that's making it with the angle between, let me call this space E, for instance, okay? All the broken lines are added lines. So the original, okay, let me break this one as well. Every broken line here are added lines to the original diagram. The original diagram has both lines. Okay, so my angle of depression is actually angle EDB. Angle EDB. So to get it, for the first question, to get it, I'm going to calculate angle, this B. This is D here now, right? Okay. So I will going to calculate the angle BDA, BDC. So I'll say considering considering triangle BCD, okay, to get BDC angle, there's a trigonometrical identity I can use because tan angle, okay, let me call the angle X. Tan X, which is the angle that is formed by BCD. Tan X is equals to adjacent over opposite over adjacent, sorry. Opposite over adjacent. So what is opposite? Tan X is equals to opposite is 30 and adjacent is 40. So X is equals to tan inverse of 3 over 4 or 0.75. That's the tan inverse of 0.75. That will give me 36.87. So X is equal to 36.87 degrees. This is what we have as X. But we're looking for EDB angle. That's the angle of depression. Angle of depression, which is angle EDB, is equals to 90 minus X, which is 90 minus 36.87. So the answer will give me approximately 53. It's 53.13. But they say we should get the approximate value. Okay, well, so this is the angle of depression. Angle of depression of points of B from D. From this point, the angle of depression is this angle that is here. Now the second question says we should calculate the angle of depression from A, you understand, from D. So that one now move to this angle. You see, there are two angles. I've chosen the first one, which is this one. This is the second one I'm going to get. Now to get this one, note that DC is the same thing as ED. Though I have part of AB, which is 26. So if I subtract 26 from 40, I'll be getting this side. So when I do that subtraction, I'll be getting 40, that is 14, should be 14. So this is 14 here, and this is still 30. So I have formed a rectangle triangle with all the dimensions. Okay, so I will now say considering triangle AED, which is this one, here. So I'm going to look for the angle of depression from at A from D. Okay, so let me call that angle Y. So if I'm considering triangle AED, I see that tan Y, which is this one, is equals to adjacent, opposite, sorry, which is 14, opposite over adjacent. Okay? Okay, so tan Y is equal to opposite is 14, adjacent is 30. So the ratio of 14 and 30 will give me 0.4667. Let me wrap up here. Tan Y is equals to 0.4667. Alright? So having gotten that, Y is equals to the tan inverse of 0.4667. So when I complete that, Y will now be angle 25 degree approximately. So this 25 degree approximately represents the angle of depression of A from B. So this is the angle of depression Y, and let me call the angle of depression is given as EDA, angle EDA. Okay, let me put it here. The first question, the angle of depression is angle EDB. DB. Angle EDB. That's the first one. Second one, the angle of depression is angle EDA. So basically, this kind of questions, just visualize it. If you can get the diagram very well, extrapolate information. All this broken line I'm having here and the external line I have to draw to, get that picture of what we are looking for. So it's very easy. Plane geometry is easy. You know the basic formula. I'm going to be giving some other questions in the comment section. Of course, description and comment section that are not like this one. So you can also have further calculation. So link us up for further lessons. And then I hope this video has been informative for you. I hope this video has been informative for you. I'd like to thank you for viewing.